I hope the shared word file is visible. So this pumping lemma will be the last topic of the unit 3. Pumping lemma we have seen regarding the regular languages also. So the statement of lemma remains same, more or less same. Minor variations are there. As you are familiar, I hope you people remember, pumping is repetition, lemma is theorem. So if particular symbol of the string or rather valid word is repeated, whether that resultant word still belongs to the language or not, and the language is context free or not, that will be decided by this pumping lemma, repetition theorem. So it says that let G be a CFG, given grammar be context free grammar. Then there exists a constant n. In previous case, pumping lemma related to RL, we have seen that this n tends to be the cardinality of set capital Q, which is finite set of states. So there exists a constant n such that any string W belonging to L of G, that is valid string, whose length is minimum n, it can be greater. This W can always be rewritten as collection of substrings denoted by U, V, X, Y, Z, all small case, such that there are some restrictions on each of these. First restriction is the length of V, X, Y collectively should be at least, at the most, not at least, at the most n, whereas W ka length should be at least n. Vxy at most n. V and Y, they cannot be epsilon because you will be pumping V and Y. And for all values of I which are pumped, if the resultant word still belongs to L, then you say that the given language is CFL. So like in previous case, here also the pumping lemma will be used to prove that given language is not CFL. You will be using the proof by contradiction. Take a minute, go through this, and then we'll start with the very first sum based on pumping lemma for CFL. So what is pumped here or what is repeated? The value of V and Y. V and Y appear between U, X and Z. So this is the first sum. You need to prove that the language of the form a raised to p where p is prime number is not context free. So as it is said that you will be using the proof by contradiction, the very first statement is given language is CFL. You need to prove that it is not CFL. So assumption is assume it is CFL. Then you should write this statement for pumping lemma. This statement that let G be the context free grammar and W be the word or string belonging to the language generated by this grammar. Choose the value of W such that its length is at least 10 and then try to rewrite it in the form of U, V, X, Y, Z. So these conditions should be satisfied. Then it's a CFL. So you say after that, let n be the natural number which represents a constant as per the pumping lemma. And as you want W such that its value is at least n, you select the value of P so that it is greater than n or at least n. So P is the value which will be now a raised to P will be divided into substrings U, V, X, Y, Z. And then you pump V and Y Q number of times and check whether the resultant U, V raised to Q, X, Y raised to Q, Z still belongs to L of G or not. Now, as the format of language says that length of each and every word will be prime number. So this a raised to P ka length will also prime. Now you are repeating this V and Y Q number of times. So the length of this W will be increased with 2 Qs. So as it is increased with 2 Qs means now length will not be a prime number because now it will be having factors because it is now original length plus addition of 2 Qs. So it will have factors. So as it is no more prime, the resultant W will not belong to the L of G or L. Why so? Because language is defined as collection of words. The length of each and every word should be a prime number. So if you try to relate this, so as no more W no more belongs to L, you say assumption of step number 1 is wrong. So given language is not CFL. So if you try to consider some value of this P, a prime number say 7, you will have A repeated 7 number of times. Right? Now consider some values of U, V, X, Y, Z such that V, X, Y is at the most N. Now we split this 7 A's considering U is double A, V is A, X is A, Y is A, Z is double A. 7 A's. So V, X, Y is of length 3. Now if you consider Q is 2 means you need to repeat V and Y 2 times. V is A, Y is A. Repeated twice means V will be double A now. And Y will be double A. Remaining U remains same, X remains same, Z remains same. So here length, if you count, will be 9, which is not a prime. You can consider another value of this P, which will be a prime number, say 11, and then you can try it likewise. So after pumping V and Y, you will find that the length of resultant string is no more a prime number because it is now increased with 2Q. So obviously it's having factor, so it's not a prime number. So that means step 1 is getting contradicted. So given language is not context free. Consider one more example. These are the examples which are asked in university exams frequently. Prove that L, that is language, with the form a raised to I, b raised to I, c raised to I, where I is greater than or equal to 1, is not CFL. You start the solution with the assumption that given language is CFL and n is the value which is satisfying the constraint as per the pumping lemma. Now you select the W whose value is length is at least n. So let us select I equal to n itself. So n plus n plus n, 3n. So W at least n you got because now the length is 3n. So a raised to n, b raised to n, c raised to n. You need to now rewrite this W as collection of substrings u, v, x, y, z, provided the length of substring v, x, y should be less than or equal to n. N we have considered in case 1 as 3. So a cube, b cube, c cube. A is repeated thrice, similarly b and c. As n is 3, we have considered vxy ka length less than or equal to 3. So all b's will be the value of vxy. So v will be b, x will be b, y will be b. Remaining left substring will represent u, rightmost substring to vxy will represent z. That's why we have written these values likewise. Now v and y contain only two symbols. V is b, y is b. So if you are repeating it, pumping it, it will break the exact same number of A's, B's and C's as per the given language format. What is the format of language? A raised to I, B raised to I, C raised to I. You have observed that the value of V is B, value of Y is B. So if you are repeating it more than one time, say twice, so there will be, see here it is written, if V and Y are pumped, let us say V square Y square double B, so Vxy becomes double B, X remains as B, Y becomes double B. So total number of B's are now 5, whereas A and C they are appearing 3 times. So length is this 6 plus 5, 11. But there are no more same number of B's as that of A's and C's. So resulting W does not belong to the language. So the assumption of step number 1 is wrong and you say that L is not a context free language. It should be true for each and every W. You should not find out such a W wherein if you are pumping V and Y, still the resultant W belongs to the language. So that will be a very specific and specialized case. What we mean here is generalized one, that each and every resultant after pumping should also belong to L. Then only you can say it's a CFL. Now here someone may say that why to consider VXY as only B's. It can be containing A's and B's, or it can be containing B's and C's. Is it possible to have all the three symbols in XYZ? If you consider the case wherein VXY is A, triple B, C, what length of VXY we are getting here? 5. Right. But N is what? 3. And you want VXY का length at most N. So it should be 3 or less, in between 1 to 3. So that's why we cannot have this case wherein VXY is containing all three symbols. I hope this is understood. If you have any sort of doubt related to this written and highlighted in red wala portion, you should ask. So we are not writing this thing. Now what other possibilities are there? All three symbols cannot be there. So case 2 में what we are considering, V and Y contains multiple symbols between A, B, C. So all threes cannot be there, but A and B can be there, B and C can be there. So now consider N is 3 only, triple A, triple B, triple C. And what all possible combinations are there, those are listed on the screen. What possible combinations are there now? VXY can be double BC. Its value cannot exceed N. So if you consider VXY as double BC, U and Z will take these values. If you consider VXY as A double B, U and Z will take these values respectively. If you consider VXY as B double C, these are the values of U and Z. If VXY is taking the value double AB, U and Z will be this. If any other condition is for any other value of VXY is possible, you should list that also. And then pump, that is repeat V and Y more than one time. So twice, thrice will do. That is V raised to I, Y raised to I. So pumping or repeating of this will result in unequal number of A's and B's and C's. For example, if you consider the case, very first case wherein VXY is double BC and you are repeating V and Y. So V square is double B, Y square is double C. So now the number of B's and C's will be more as compared to A's. But the format of language is A raised to I, B raised to I, C raised to I. All should appear in particular order and in equal number. But now in resultant, number of B's and number of C's are more. So resultant no more belongs to the given language. Step number 1 is getting contradicted. Take a minute, go through the solution. From here the problem starts. As you are pumping V and Y cannot be epsilon. It's written here Py not equal to epsilon, cannot be blank. This cross wrong. So this is the last topic of unit number 3, grammar. Now we'll start with the next unit number 4, which is push down automata. PDA, push down automata. Related to FA, we have seen that you cannot draw FA for A raised to n, B raised to n. What is the reason, if you may recall? That FA doesn't have memory to remember how many times A is been repeated and then repeat B exactly same number of times. Go through this statement. This is the reason why we cannot have FA for A raised to n, B raised to n. So there is the need for FA with memory so that you can represent this with the help of diagram. So what you want? FA with memory. And that FA with memory in the form of stack is nothing but PDA. So this is the basic concept why there is need for PDA and what exactly PDA is. FA with memory in the form of stack is giving you PDA. Now what is FA? These are the 5 tuples. Q summation del Q0 F. We have seen this from the very start, 2-3 lectures. Formal definition of FA. FA is an automata denoted by M, collection of 5 tuples, where they are defined as Q is finite set of states, sigma or summation is a finite set of input symbols, Q0 is initial state, F is set of final state or states, del is transition function defined as Q into summation gives you Q. So this you are familiar with. Now what part you need to add? memory in form of stack. So when you say you are adding stack, related to stack, there will be the stack symbols and initial stack symbol. So you are using this gamma notation, Z0 notation for the stack symbols and initial stack symbol respectively. So these 5 tuples along with these 2, now 7 tuples, define PDA formally. And that's why PDA is listed likewise, collection of 7 tuples, Q summation gamma del Q0 Z0 F, where Q is finite set of states, sigma is finite set of input symbols. Input symbols are always stored on a tape which is divided into different cells and which has infinite length. Gamma, finite set of stack symbols. Z0 is one of the stack symbol, initial stack symbol. Q0 is one of the state, initial state or start state of PDA. Capital F is finite set of final state or states. Del is transition function. This is how you will visualize the input tape, which is finite, which is infinite in length. We are considering the sum a raised to n, b raised to n. N is considered to be 3. So you find here 3 a's in the respective cells, 3 b's immediately following 3 a's. A3, B3. This is visualization of tape. Again you need to visualize or imagine it is infinite in length. So there are n number of or many more cells after this. Now you need to visualize that a B, if you consider n is 3, these are only 6 cells. But consider this tape has a length up to 1 kilometer and number of A's are there followed by number of B's. So obviously the scope of tape is not within the reach of your eyes. So like in this example, you cannot count the number of A's and number of B's and tell whether they are equal or not on the input tape which has length at least 1 kilometer. So now you need to consider what can be the way on such tape to check whether same number of B's are following A's. So if you consider there are 2000 A's, whether 2000 B's are followed by 2000 A's or not. Counting is not possible. When you talk of a machine, everything is mechanical. Because at lowest level, mechanical parts are only working. So how you will be verifying whether same number of A's and B's are there on the tape? Take a minute, try to think. क्या visualize करना है आपको? There is a tape of length 1 kilometer. You don't know how many A's are there, how many B's are there. First, n number of A's are printed on the tape and then printing of B starts. And now you need to verify their numbers are equal or not mechanically. Tape is not visible to your eyes. So striking of B for each A encountered can be the mechanical solution. Striking of B for each A encountered. So now consider how many no color. ये क्या है कलर फील है शायद इट्स नॉट हाईलाइटिंग consider this is the case do not count number of A's and number of B's so mechanically what you are supposed to do is by वन ही करना है शायद now consider that this is the A encounter you are at this end at the start for this A encounter let us strike off this A and go to this end in a search of B. Go to next step. Is it B? No. Skip. Is it B? No. Skip. 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 You got B. As soon as you got B, strike it off. It means that for each A encountered, you are striking off one B. Again, come back to this cell where you find striped A. Go to right of that. So this can be the mechanical solution. So how you will do with the help of memory? This each and every A will be added to the stack until B is encountered. And as soon as B is encountered, one A will be deleted from stack. So that operation in the visual representation form we'll see shortly. Before that, theoretically you need to remember that PDA push down automata is nothing but FA with memory in the form of stack. Added stack will provide some increased capabilities to the machine, that is FA. So what are those increased capabilities? That it can read the input symbol on tape. FA maybe this is applicable, but it also performs some stack operations. So basic stack operations you are familiar with: adding or pushing on stack, deleting or popping from stack. Next is check whether the stack is empty and reading top of the stack symbol. These are basic stack operations. And if required, make the changes. So with this added memory, PDA will obviously be more powerful than FA. FA can recognize only RL, and RLs are subset of CFLs, regular language, context-free language. Now PDA can recognize the larger set which is context free language, CFL. So you say that as PDA can recognize CFL, the language of PDA is CFL. So for every CFL, there will exist a PDA. As we say in case of regular languages, if the language is regular, for every regular language, there will exist one FA. So for every CFL, there will exist one PDA. Take a minute, go through this theoretical part, introduction of PDA. Now, how you will be representing this in form of symbols. So consider this is your tape wherein input symbols are stored, and this tape is infinite in length. Then you said reading of symbols on tape will be done. Finite state control is there which is doing the reading, and stack operations. So this is stack which is initialized with the stack initialization symbol which is Z0. So likewise you can consider this stack also has infinite number of cells, but only topmost cell is initialized with the Z0. Whatever comes will be stored in this vertical manner. You are familiar with these things. So this is your basic PDA. While writing the short note and explanation about PDA, you should include all these things along with 7 tuples, explanation about 7 tuples, and this visual representation. Now we come to the first part. AAA, triple B are there on input tape, and you have the initial state of the PDA Q0. Finite control will always point to the very first symbol on the input tape, and that is considered to be by default the leftmost symbol. So Q0 is the initial state, A is the very first input symbol, stack is initialized with Z0. So transition is written likewise, del of Q0, comma A, comma Z0. What is the output of this? As per transition definition and the logic of this problem, you are supposed to add this A to the stack. So visually this A is represented likewise, that it is added now above Z0. Using mathematical modeling, you will say that you still remain in state Q0. A is added as top of the stack symbol. So addition or push on the stack is represented likewise. The next state, it remains as Q0, comma, two topmost symbols of the stack in sequence. TOS, top of the stack, and then immediate symbol below it. Here you consider del is there. Let us copy. So this is the format of transition. Related to the PDA or push operation, which is defined in form of transition. So del of Q0 comma A comma Z0, it means you are in state Q0, input symbol is A, current input symbol which you need to process, top of the stack is Z0. You get next state as Q0, action performed is addition to stack, push on a stack. This is how you list it, and this is how the visual representation is. This A is transferred to stack. For the same sum, this A should also be added to the stack. This A should also be added to the stack. So how they are visually represented. Now next step is you are in Q0, top of the stack is A. So you find here Q0, top of the stack is A. And the current input symbol is also A. So state current input symbol top of the stack. Here we will add that. What we have? We have state. Which state? Current state. Current state. Next comes current input symbol and then top of the stack. It's giving you what? It's giving you next state, and whatever is there after this will depend on stack operation. So if it is addition to stack, it will be represented likewise. If it is deletion, it will be represented in some other form. So now next state you start with Q0, top of the stack you start with A. So Q0 A. Right. So here if you follow the same sequence, and write so next state we got Q0, top of the stack we got as A, and current input symbol is also A. What operation you are performing? Stay in Q0 and add this A. कौन सा A? This is input, yellow highlighted to top of the stack. So now this stack representation is Z0 के ऊपर हमने A ऐड किया था लेफ्ट मोस्ट, उसके बाद वाला middle A is also added here. And now finite control read write head will move to this third A. So you will find it's now pointing to third A from the left. You are in Q0, top of this stack is A, and input symbol is also A, third A, and that you need to add on stack. So push on stack is the action. This is the visual representation. All three A's are added to stack. Now, as per the logic of this sum, what you are supposed to do? For each A on top of the stack, or for each B encountered, you need to delete one A from stack. So this pointer is now moving likewise here in the next visual representation. So it is pointing to B. You are in which state? Q0. Top of the stack is A. So you write Q0, top of the stack is A. But current input symbol is what? It's B. So what should be the action? When you are in Q0, you want to process B, top of the stack is A. So for each B encountered, you delete one A from stack. So now as soon as you find some other input symbol than A, you switch the state. So now you find that you have entered a state Q1 and action you are doing is pop A from stack. So how it is represented? By adding epsilon to top of the stack. So now you are in Q1 and you add epsilon to top of the stack. That A is removed. You had 3 A's and Z0. Now this A is deleted. Popped means it's been replaced by epsilon. So top of the stack is now non-null symbol A. Now you are in Q1. Top of the stack is A and you want to process this middle wala B. So next visual representation tells that you want to process this middle wala B. You are in Q1, top of the stack is A. You want to process B. So for this second B encountered on tape, you will delete one A from top of the stack. So you remain in Q1, you add epsilon on top of the stack. So that represents pop from a stack. Pop A symbol from stack. So that A is replaced by null. You are still in Q1, top of the stack is A, you will consider rightmost B or processing. So finite state control is pointing to this B. You are in Q1, top of the stack is A. You want to process B. So for this third B encountered on tape, you will delete this A from top of the stack. Deleting means replacing it with epsilon. So you stay in Q1, comma, top of the stack is epsilon. Pop from stack. What to pop? Pop A from stack. So now top of the stack is pointing to the stack initialization symbol Z0. And this will point to the next cell. As you are done with all input symbol processing, the next cell of input tape will be blank. It will have null character epsilon in that cell to represent that it is blank. So now you are in Q1, top of the stack is Z0 and input symbol you want to process is epsilon. It means that no more input symbols are there on the input state as well as no more A's are there on the stack. Means for each B on input tape, you have cancelled one A. And as there are 3 B's as well as 3 A's, you have no more symbols on stack as well as input tape. For each B, one A got cancelled. And that's why this empty condition is denoted by you are in Q1, stack is in initialized state, input symbols are exhausted, so you go to final state Q2 and you let stack be in initialized condition. And this is no operation but halt state. And by now you are sure that equal number of A's and B's were there. So you go to Q2 and make it default or accepting state. Same thing is depicted here. You are in Q0. You encounter A. Top of the stack is initially Z0. So you do push A operation. You stay in Q0. You encounter second A. Now top of the stack is A. The second A is also added to the stack. You stay in Q0 only. You encounter now third A. Top of the stack is A. Third A is also added. Next, fourth symbol is B. In Q0, you encounter B. Top of the stack is A. First, you change the state, you go to Q1 and delete that A from top of the stack by adding epsilon to it. Now you are in Q1. You will now encounter only input symbols B. So for each B encountered and for each corresponding A on top of the stack, you delete that A. While doing so, you find that there are no more symbols on tape, no more symbols on stack. It means equal number of symbols were there on stack as well as tape, A and B. Equivalently, they got cancelled. Now, nothing is there on stack. Let it be Z0, stack initialization. Go to the final state. So even if there are 4 A's, each and every A will be added to the stack. As soon as you find B, you proceed with the pop operation. If more number of B's are there than A's, then you will find that B symbol is still there, but there is not corresponding A on stack. So it won't go to this Q2, because in that case you will encounter B, comma Z0. B will be the input symbol on tape, Z0 will be empty stack. So B is there, but A is not there. So there is no transition defined likewise. So it won't reach to the final state. So that string won't be accepted. So now this is the case where number of B's are greater. If number of A's are greater, then input symbol will be epsilon. But top of the stack will contain A. So that will be epsilon comma A. That transition is also not defined. So it won't end in Q2 final state. So won't be accepted. So this is PDA for A raised to n, B raised to n, which is asked frequently in university exam. Consider some random value of n for A raised to n, B raised to n and try to trace that string using this PDA. By that time, I will share the attendance list. Mics are provided. If you have any doubt, you should ask. Attendance link is active. Mark your attendance. Go through the PDA diagram. Consider valid as well as invalid string of the form a raised to n, b raised to n. Try to trace using the given transition diagram for PDA. In case of doubt, you should ask. Remember the logic. Logic is to push all the A's on stack. As soon as you encounter B, delete or pop one A from stack for each B encountered. What is the format of writing this? It is A is what? Current input symbol, right? Z0 is what? Stack symbol. Or top of this stack. Then comes slash and then comes stack operation. So this is the generalized format of writing the transition. Current input symbol, comma, top of this stack, / stack operation. So here current input symbol is B, top of this stack is A, stack operation is pop. Current input symbol is null, symbol epsilon, top of this stack is stack initialization symbol Z0. It remains Z0 means no operation, no change in the stack condition. If no doubt, you may disconnect.